V1, V2, I think it's quite very simple problem. M1 GH equal to M1 V1 square plus M2 V2 square. Then applying conservation of linear momentum, the release from rest system. So M1, M2 V2 minus M1. Solving this, I'll get V1 and V2. I think clear, no problem. So we have to work out. There's no other way. We have to get V1 and V2. Then afterwards, what is the state of this? You can directly take the relative velocity approach. No? So what is the distance BC is equal to L? This distance is equal to L. So there's a, just go for relative motion between C and point B and C, or between the block and point C. They're moving opposite to each other. It is make problem very simple. This is V2. This is V1. What is the time taken by them? Block to travel from B to C. Finally, they'll meet, no? So this is C, this is B, will take it. So in this case, what you write time? Time should be equal to L by V relative. Here is what most of students, they went wrong. Nothing to do, like a treat point C is will have a velocity V2 and point B, not point B, the block. You have to discuss the relative motion between the block and the point C, not point B again. I'm making things clear. So V1, V2, you know how to calculate from here. You'll be shocked, almost 70% students could not do this problem in the grand test when it is given. Just be careful about the small ideas in final advanced exam. I think this is what happens for most of students. Like, so will it be exactly at position of B? We don't know. They may ask you those things also. You have to be careful. When the block C reaches there. So can we calculate the displacement, like how much the wedge has moved on? So anyway, we have the data, no? So the displacement of wedge should be this much. The displacement of block should be this much, because we know T also. So what is that? I'm showing X2, this one. And what is that X1, the displacement of the block? I'll slightly displace it. This will be, or we'll keep it somewhere here. I'll slide on. Anybody taking printout or something, make observation, I'll slide on.